welcome to the Open Systems Media eCast titled On the Road to Space Age Vehicles, Developing for the Convergence of Consumer Electronics and In-Vehicle Entertainment. I'm Kurt Schwader, your moderator, with today's speakers, Manpreet Singh from IBM Rational, Andrew Patterson from Mentor Graphics, Yuri Wallach from Polarian Software, and Linda Gaines from Vector Software. Today's schedule consists of about 50 minutes of presentation, leaving about 10 minutes at the end of the hour for the audience Q&A. Before we begin, I'd like to run down some features of your console. First is the Enlarge Slides button. This button will maximize the slides to fill your entire screen. The Download Slides button will allow you to download and print the slides if you'd like a hard copy to follow along with. The button labeled Forward to a Friend enables you to send an email to someone. That will include a registration link to this eCast so they can also attend. The Ask a Question text box enables you to participate in today's event. You simply type your question into the box and submit it using the Submit button. You can submit questions at any time during the presentations. We encourage you to do so early and often while you're looking at the material in question and it's fresh in your mind. We'll address as many of the questions as possible during the closing Q&A. And if you have a question pertaining to the eCast operation itself, you could submit those too. And one of our technicians will be happy to respond to you. Manpreet Singh leads marketing for IBM Rational Solutions for automotive systems and software engineering. Manpreet has a broad range of industry and technology delivery experience and has previously held engineering positions with companies like Siemens AG and Microsoft Consulting. At IBM, he has worked as Rational Solutions Consultant, Software Architect, and Product Manager for systems modeling tools with specific focus on the automotive industry. He has extensive experience in helping IBM clients be successful with the software. Manpreet earned a master and bachelor's degrees in computer science from the University of Pune. Manpreet, the floor is yours.
Thank you, Kurt, and welcome everyone once again to this webcast today. Let me take you to the next slide. So I wanted to start off before jumping into what IBM solutions do and helping address the needs for modern entertainment systems. I want to take a step back and understand what exactly are the needs, developmental needs of these systems today. And one of the major challenges that or crossroads that we are facing these days in the automotive industry is that we have developed quite a few fundamental building blocks of systems over the past few decades, and these electronic systems are very complex, very well optimized, and very well balanced. But the new innovations are not localized to these individual domains, as we call them in automotive engineering. And they are the new features that we develop cut across the whole network of the car. And this presents us with a set of challenges which we as developers haven't been very adept at facing in many ways. So what this slide is trying to basically tell is the maturity level that we have in our engineering organizations in general is very high when we try to develop individual subsystems within the car. But the moment we are trying to develop features which cut across these systems, the maturity level in terms of our processes and tools, the backbone that supports the teams that work on these features tends to diminish. And this problem gets even more exaggerated when we try to develop features that are not even localized with the car. They cut across industry boundaries, which have different innovation cycle rates, one having electronics doing it per month to energy doing it in decades. And, different industry people or users of these industry solutions tend to have unrealistic expectations from the features that tend to develop at the intersection of these different ecosystems. And this compounds the problem of the delocalization of the new features that we are developing. to give a more physical architecture view of, for example, a connected car. The connected car is really a part of the system of systems network, and as you see here, it is interacting with many other networks apart from only the embedded networks that are embedded within that car. So with this background about how the systems are evolving and how systems are becoming more important, let's try to understand the different layers of architecture that we need to do development at these days and be adapted. So at the very bottom you see there is embedded systems. We have been used to doing development in these places and have very good tools and solutions that help us do it, have very good assets currently in this space. But then again, as I said, you are seeing many new features being developed that are interacting, that have many more interactions between the boxes. You go one level higher, and that's where the systems engineering starts playing a role, where you are doing much more multidisciplinary engineering, where electrical, physical, mechanical, and software engineering all need to work together to deliver a solution. So your ability to collaborate between teams, multidisciplinary teams, is very important. And then the final layer on the top is the systems view of the whole product as it plugs into the other ecosystems. So rather than trying to give you the product names of our solutions, I wanted to discuss a few success stories that our customers have had over the past using our solutions. The first one I want to mention from the embedded solutions perspective and systems engineering perspective is Jaguar Land Rover, who achieved 90% reduction in their software validation time up to, and implemented a integrated set of tools to help them work in a globally distributed organization with teams dispersed over the whole continent, and achieve very high efficiency in their embedded solutions. The next customer I want to discuss was none other than BMW, who, as with all many other OEMs, are trying to adopt AUTOSAR, leading the way in many ways by AUTOSAR adoption, and use our tools again to help achieve compliance with the standard. Again, this is at the second layer, systems engineering layer, where multiple systems are being integrated using AUTOSAR standard within the car, a standardized way of automotive EE engineering. The next customer I want to discuss, the third layer, the right on top of layer, systems of systems, is where the Daimler Fleet Board, a truck company, basically used not just a solution within the car or the truck to optimize the fuel consumption, but how the whole fleet works collaboratively and cohesively in reducing and being much more efficient in terms of their fuel consumption. So with those three examples, I wanted to take you to a unifying look on the whole solution that we have, which basically brings collaboration between different engineering disciplines, and it helps you access all the engineering information from different tools based on open standards integration. So it is not just IBM tools, it could integrate tools from any other company based on a completely standards-based open approach, and it helps you provide traceability throughout your life cycle, which is the foundation for all the other efficiencies in terms of and a tighter needs to realization life cycle, which is very much required for compliance to new standards, safety standards like ISO 26262, where the traceability needs are much more stringent. With that, I would like to invite you all to participate in our upcoming symposium in Detroit, and this is where you can learn more about our solutions in depth. In case you cannot make it, the whole conference content will be published online, so keep a watch on that. The registration URL is provided there. And with that, I'd like to hand it back over to Kurt. Thank you. Thanks for your interest.
Thanks, Manfred. Our next presenter is Yuri Wallach, a senior product manager for Polarian Software, With 15 years of software development, Jiri has worked in visionary projects applying the Meta Object Facility Standards for model-driven engineering to project manager and researcher focusing on user experience, playing an integral role in the development of Polarion software. Polarion application lifecycle products, which Jiri leads, help thousands of companies and millions of users collaborate and develop more efficiently. Jiri holds master's degree in mathematics from the Charles University in Prague, Czech Republic. Jiri.
Hello, everybody. So before I would like to speak about Polarion solutions for automotive software development, let me just introduce Polarion Software. Polarion Software is a leading innovator in web-based requirements management, quality assurance, and AOM solutions since our first product release in 2004. And the success of Polarion is best described by hundreds of global 1,000 companies and over 1 million users who rely daily on Polarion solutions. So what are the challenges specific to automotive development? Actually, whenever we speak with customers from automotive industry, they mention their projects are very complex. Just read the following statements. The radio and navigation system in current S-Class Mercedes-Benz requires over 20 million lines of code, and that car contains nearly as many electronic control units as the new Airbus A380. So you need really to deal with component specifications with more than 50,000 of requirements in total, and such project complexity spans over the full project lifecycle. So in general, more and more hardware components require software to control the function and user interaction, and components are massively reused between different variants and different versions. So most of the new car functions are safety-related. No matter if you speak about autopilot systems or a multimedia system, there is an increasing need for risk management to achieve acceptable residual risk. You must comply with regulations like ISO 26262 or meet regulatory standards like CMMI or SPICE to achieve transparency in distributed environments. And even with the increased focus on quality and safety, there is a pressure to release the new versions fast. The ability to handle a change, even late in the development cycle, is now widely accepted not merely as a best practice, but as a prerequisite to success in a world of increasing competition and shrinking resources. So to meet the quality and safety requirements, the teams really need to understand the impact of a change before the change actually happens. And last but not least, the collaboration. I mean, it's common agreement that Agile and its derivatives have a positive impact on quality and time to market. It has a strong emphasis on the smooth collaboration. And unfortunately, very few companies have teams being located on a single place. Contrary, the teams are often distributed all over the world, and AOM tools have to ensure the instant collaboration of all the team members wherever they sit. So how Polarion solutions help to meet those automotive challenges? The project's complexity, as described, with high ratio of components, reuse, typically requires a high flexibility of a domain model. And Polarion ALM is absolutely flexible to customize the model and process to manage any kind of artifacts, requirements, software, electrical specification documents, test plans, whatever. We clearly see a high value in ease of use as a prerequisite to ensure the users are using the tool and follow the process as it was stopped. So it's not just the ability to manage those artifacts, but also then to enable import and round trip. By round trip, we mean the ability to export and import the changes back using tools that people are used to work with, like Microsoft Word or Microsoft Excel. And this improves the user adoption of ALM solutions heavily. And of course, when speaking about organizing existing information, we also need to integrate with smoothly with UML or system modeling tools. Historical traceability. So what is actually traceability? Traceability refers to the completeness of the information about every step in a supply chain. So first you have to ensure that every modification is traceable. Every step is uniquely identified. And Polarion stores everything in a single version control repository. And by everything, we also mean, a process configuration. And this is often mandated by regulatory standards that you have to document not just the product changes, but also the process changes needs to be documented, versioned, and qualified that there is no risk on functional safety process. Now the requirements traceability. Requirements traceability is concerned with documenting the relationships between requirements and other development artifacts. Not only requirements themselves should be traced, but also all the other artifacts like test cases, test procedures. And so what matters in requirements management is not a temporal evolution so much as a structural evolution, a trace of where requirements are derived from, how they are satisfied, how they are tested, and what impact will result if they are changed. So it's not a goal to show a link between a requirement and a test case, but to give really a proof that all the released requirements have been verified. And again, you have to ensure this in a highly complex environment when requirements are branched in different variants with links across the projects and reported from any baseline principally. So this fact that all the artifacts are managed and visible in a single Polaris repository can be linked with current or any baseline of any other artifact has been reported as one of the top 3 reasons why our customers select Polaris ALM. First, regarding safety, most of the new car functions are, as we said, are safety related. And second, the regulations for automotive development tends to be more and more complex, with more strict requirements on the actual process. And the functional safety is an integral part of each product development phase, from the specification to design, implementation, integration, validation, of course, product release. And actually, Polaris ALM is the first solution with all the ALM components being qualified for ISO 26262. The TÜV Nord qualifies Polaris ALM support the development of products that conform to ISO 26262, and as well as the process of how Polaris handles requirements, defects, products, enhancements, etc. And it was actually a pretty interesting observation that we were the first company certified by TÜV Nord that is using an agile process, as Polaris R&D team is using Scrum. And our agile process does not rely on the team verbal communication, as is often oversimplified by agile enthusiasts, but heavily rely on the traceability and collaboration of team members using Polaris ALM, and this allowed us to pass this certification pretty easily. So also part of this qualification was not just the tool certification, but also a project template certification for ISO 26262, support for hazard analysis or FMEA standards. Polaris is unified by design. We have a single repository, 100% web-based, no client-side software to be installed, role-based interface so users can share the data, but the user interface is fine-tuned for each role differently. And for global collaboration, we were typically able to ensure a global access all around the world with a single deployment, no need of replicas or synchronization in multi-site environment when accessing requirements, test plans, or development tasks. And on the other hand, development teams can still connect their distributed version control repositories running on different continents for source code change traceability and still benefit from a local network access time. So I already referred to Agile to have a positive impact on the quality and time to market. We certainly see an interest and wide adoption of some of Agile practices and implementation of hybrid processes at our embedded software and automotive customers. And the goal is to achieve both formal and informal collaboration with, for example, activity streams supporting the instant look into your project, to formal approvals with support of electronic signatures as an example of a formal collaboration. So at the end, let me also share with you an overview of an automotive SPICE-conformed development environment as it is used by Fujitsu Semiconductor. is a deployment to 3 different locations, EU, Japan, and the US. You see some version at the bottom. I mean, this is the version control repository to hold all the Polarion artifacts. The SPICE process was set up to cover the full software development cycle, requirements, specification, driven mainly by Polarion, software design supported also by the UML tool Enterprise Architect, project management, change management, everything covered by Polarion with run through this Microsoft project. But what is really important is the quality assurance part. We call it a test hub. And what we see is that actually customers are typically using a wide portfolio of testing tools. They do not rely on a single vendor for test automation. And with Polarion, you can manage not just the manual tests, but you can also really import easily the test results, not just the unit tests, but also hardware in the loop tests, static source code analysis failures, and process the results in a unified way. So no matter what kind of test fails, the issue is automatically generated and assigned to a developer. And this agile practice of a frequent releases and testing of software as soon as possible, with unified processing of test results, ensure that this issue is being really investigated much sooner, and it takes less time to be actually fixed. You see that Fujitsu is also using some of the tools of one of the next speakers, Vector Software. So I think this is a great opportunity to finish our part. And if you are interested, you can download a white paper from our website or just contact us via email. Thank you very much. Kurt, please.
Great.
Go ahead.
Thank you very much, Yuri. Our next presenter is Andrew Patterson. He is a Business Development Director for Mentor Graphics Embedded Division, specializing in automotive solutions. Prior to Mentor, Andrew has spent over 25 years in design automation and IT engineering markets, working in the areas of vehicle networks, simulation model development with VHDL and VHDL-A, virtual prototyping, mechatronics, software test, and software build. Over a past year, he's been focused on Mentor's Linux-based automotive infotainment and instrument cluster solutions and requirements in this fast-evolving market. Andrew holds a master's degree in engineering and electrical sciences from Cambridge University. Andrew.
Thank you very much, Kurt, for the introduction. And welcome to everybody, and thank you for your time today. I'm going to speak about the platforms that have enabled infotainment and consumer electronics increasingly to converge. In the old days, this platform was a single black box that would fit into behind your car dashboard, and typically neither the car maker nor the consumer would take a look inside it. If it broke, you would replace it. As time's moved on, more and more is having to fit into that platform. Telematics capabilities, enabling cars to communicate with infrastructure or with each other. Entertainment, obviously. Smart device links, tablet integration, smartphone integration. Advanced navigation aids. Driver assistance features like round car radar, round car cameras, and a whole lot more. And if you actually cost out what it would take to build all that, to integrate it, to develop it, to put it into production, it would be way more than the car could sell for. Also, the timescales would be too long to allow all that to develop. So over the past few years, car makers have been looking to solve those problems by moving to open source, looking for standard platforms, looking for reuse, looking for common areas. And I'm going to speak particularly about infotainment and the use of open source in infotainment systems. One of the most important enablers for any technology change is communication. And cars are increasingly becoming communicating devices. Over 150 years ago, people and machines weren't talking to each other. It seems relatively recent in the overall history. And in fact, the first mobile connected car was back in 1910. One Lars Ericsson, famous for the Ericsson company, hooked his car up to some overhead wires, and he was able to communicate to base stations. If we fast forward to present day, there's almost one mobile phone for everybody on the planet. So it's been a complete communication turnaround in the last century. Not only now is it people, it's cars, and obviously the Internet of Things. So over the next 10 to 20 years, one of the major changes will be cars communicating with each other and with infrastructure. The other dynamic on the industry is the pressure from consumer electronics. And I'm going to speak particularly now about Android smart devices. These statistics are from last month. There are now over 850,000 Android apps in Google's Play Store. And a total of over 1 billion Android devices have now been activated, around 1.5 million every day. And just looking at market shares of operating systems, the current run rate is something around 80% in terms of smartphone market share, Android versus the rest. And the rest is very much Apple, iOS, and some other minor operating systems. So while we are looking at this in terms of automotive, well, the experience people have on their smart devices, on the Android tablets, on the Android smartphones, they very much want some of that in their car. And I'm going to talk in a couple of moments about how we enable that integration. Looking at the underlying platform, though, I said at the start, car makers and the designers are looking at using open source more and more. One very strong candidate for an open source platform in the vehicle is the Linux operating system. Linux comes in many, many variants. There are over 100 to choose from. And 2 or 3 of them have been selected as starting points for automotive infotainment. The Yocto distribution is one, Tizen is another. There's a small number. But starting with Linux isn't enough to make a car infotainment system. There are other pieces you have to add along the way. And this slide shows some of those components as we walk through. So first there's an alliance called the Geneva Organization, founded in 2009, has now around 180 members. And the Geneva Organization set out to build a standard infotainment platform. And over the past 4 or 5 years, members have been contributing reusable, shareable code that could form a great starting point for infotainment. The first Geneva platform goes into production later this year, so it's really come to maturity. However, it's not enough. There are other pieces that need to be added once you've taken this starting point. And companies like Mentor Graphics add additional Linux recipes that enable additional features. We then need to choose a board support package, a piece of hardware that is fit for starter production, SOP as it's called in the automotive industry. Then, of course, we need to put some applications on top, obvious things like navigation, multimedia, entertainment, and increasingly the apps will differentiate the vehicle as car drivers and their passengers look for more functionality. The human interface layer is becoming increasingly sophisticated with head-up displays, touch screen, in parallel user controls, voice recognition, in the future gesture recognition. And when you've built all that, you then need to very thoroughly test and QA it to get it into production. So companies like Mentor provide the tool chains and support to enable that process flow and take what starts as an open source, available to anyone package into a production-ready system. So I mentioned Geneva as the organization offering a very strong starting point for entertainment. I'm not going to drill into all the detail of Geneva, but it provides a very complete collection of packages here in all the different areas of entertainment. So these are all open source packages. It costs nothing to download them, but the hard work comes in integrating them and making them all work together. So this is the Geneva working set of open source. Every 6 months, the specification is revised and a new starting point is published to anybody who may need to use it. I said earlier there was a wide choice of possible Linux operating systems. One alternative that is has been established is called Automotive Grade Linux, AGL. It's hosted by the Linux Foundation. And the goal of AGL is to actually look a little bit beyond infotainment and set up a strong Linux distribution that could be used in different parts of the car, perhaps in instrument clusters, climate control, communications devices, so to become a Linux in the vehicle. It's a coexisting Linux alongside Genevi, and it's been promoted by a number of different organizations, some of whom you can see on this slide here. Initially pioneered by Toyota in Japan, but has a reasonable following of companies across the globe. It's had limited take-up so far, so this is early days for AGL, but an interesting distribution to watch as we go forward. Another alternative, while we're covering Linux distributions, is Tizen. Tizen's a little bit more established than AGL, and again, it covers more than just automotive. It's found its way into smart devices, set-top boxes, and other consumer electronics equipment. Like AGL, it's hosted by the Linux Foundation and has some quite strong features. One, enabling technology for programmers is the HTML5 language, allows applications to be developed and ported very easily, and Tizen has strong support for HTML5. However, it's also suffered a little bit from slow take-up, perhaps confused positioning with AGL, and again, limited commitment in the automotive OEM community. The overall ownership, you could argue, is a little bit unclear as well. There's no single organization managing and developing Tizen. So the theme of this webinar session was how do we converge consumer and infotainment. One of the most important things to the consumer is to really enjoy what he has on his or her smartphone in the vehicle. And you could say, well, I'll just get a piece of Velcro and I'll stick my smartphone to the dash and then I'm done. That's probably not a long-term solution, and it also feels very temporary. So getting Android into a vehicle, there's a number of ways to do that I'll talk about here. I'm not going to cover them in detail because of the time, but I'll talk about how to tether a smart device, perhaps more securely electronically. Other options include running Android on what we call bare metal, so install Android on the silicon platform and run that as a complete operating system in the vehicle. Techniques such as hypervisors enable a hardware platform to be shared between multiple domains. So if I've got a single silicon platform, I can run a Genevi Linux on one half of it. I could run Android on another. And in fact, that concept is extendable to run multiple domains on a single system-on-a-chip platform. Another solution to getting Android into the vehicle is a technique called Linux containers. And again, Mental Graphics has been heavily involved in some of this work. So the scenario here is that we would have a Linux host operating system and run Android as a guest in a container environment. So this way you can securely run Android and not risk it affecting some of the underlying, perhaps more important, more secure systems in the vehicle. Just to speak a little bit about the first of those options I mentioned, which was tethering a smart device into a vehicle. And the picture here in the inset shows a handheld smart device with the same image on the infotainment head unit. Some people call it BYOD, bring your own device. And of course it has the advantage that you have your favorite music, contact lists from your smartphone replicated in your vehicle. It could also be used as a hotspot provider using your existing smartphone data plan. As I mentioned just now, though, against this solution is that it doesn't really stay with the vehicle, and there is no style or brand compatibility with the vehicle, and it doesn't meet the needs of upcoming legislation for summoning emergency services if you have a misadventure with your car. So car makers are looking at more permanent solutions where you can embed the communications devices into the vehicles. So embedded 4G or LTE modems are becoming increasingly popular. But I think we would all agree that it's quite nice to have a way to connect your phone into the vehicle. And in fact, a consortium has been set up to enable this. The Car Connectivity Consortium is looking for standard ways to tether smart devices to infotainment systems, and you can control which apps are available on your infotainment head unit. So this is quite a nice way just to manage and drive apps from the driver or passenger position. Another critical area of technology that we're heavily involved in at Mentor Graphics is enabling systems to boot quickly. If you switch on your computer at home, it'll take anything a minute or more to boot up. Linux is similar, and we've been looking at ways to get this down to a small number of seconds or even sub-second, so that if you're looking for rear camera feeds, audio alerts, driver information screens, they can appear very quickly. So there's a whole amount of research going into Linux fast boot, kernel optimization, and we've been running separate webinars and events on this technology. Reordering the boot process, delaying non-critical functions are some of the techniques we can use to get fast boot working efficiently. And of course, the whole suite of tools that enables this development is available from a number of vendors. Mentor has its own solution called Sorcery Codebench and Sorcery Analyzer to allow different operating systems, applications, and userware to be integrated together and transferred to a test runtime target. We can also run these in a virtual environment, so you can debug on a host PC, perhaps if your end target isn't yet available. So time didn't allow us to go into too much detail, but I hope that gave you a quick overview of some of the platforms for infotainment. If you'd like more information, please visit the website, mentor.com/IVI, and we're open for any questions at the end of this event. So thank you again for listening, and I'll hand back to Kurt. Thank you.
Very good. Thanks, Andrew. Our final presenter is Linda Gaines. She has nearly 25 years of experience with embedded software development, including testing, training, and consulting of application software development tools and techniques to real-world projects. Linda is currently the Director of Product Marketing for Vector Software, a leading manufacturer of embedded software testing tools for safety-critical industries, where she's working on the education of Vector Software's customers and how to address the complex testing challenges they face with improved automation. Linda holds a BS in Computer Science from Trinity College and an MS in Electrical Engineering from University of Rhode Island. Linda, the floor is yours.
Thank you, Kurt. So as we heard a bunch of people already talk about, the amount of code going into these automotive systems is growing from a lines of code perspective and growing from a complexity perspective. And it appears that the IVI systems are the most complex electronic system in the car at this point. With more code and more complexity come more bugs. And so what I want to talk about now is testing and making sure we've got quality products going out. Right now, software defects account for 27% of all the car failure claims. So clearly, that's something that needs to be addressed. So the question I ask you is software only critical if someone dies? The IVI systems are not considered to be safety critical, but that doesn't mean they're not important. Complaints about in-car electronic systems rose significantly last year. And in fact, complaints about one industry-leading infotainment system helped to drop them from 5th place to 27th place. So with social media out there, you can't really escape bad things getting out to a lot of people who are making car buying decisions. And as we know, the cost of fixing a defect is a lot more expensive after a car or anything else has been released to the market, 10 times higher in this particular quote. So what does that mean? That means That's an impact to an organization's revenue if they can't make sales because they have an inferior IVI system. It impacts the expenses of the organization because now they're fixing things that are a lot more expensive to fix via recalls, and therefore it affects their brand reputation. And so while they're not safety critical applications, they certainly are business critical applications. So what are you doing to test your embedded software? Some of the things you want to ask yourself and your project are, how do you know you've tested all the software in your system? Are you confident you've eliminated as many bugs as possible? Do you have a repeatable test process to find regression errors? What static analysis tool did you use? Have you done analysis to find runtime errors? And so even though the IVI systems are not considered safety critical, I think one of the good things that projects should do, or one of the smart things projects should do, is look to the standards that exist that the safety critical components do reference for guidelines on how to get started themselves. And so there's a couple of places that you can look. The first one is the MISRA standard. That's the Motor Industry Software Reliability Association. And that's a coding standard that's been around for a long time in the automotive industry. And it really focuses on encouraging projects to use a subset of the C or the C++ language when they develop their applications that gets rid of some of the code constructs that may be not fully defined and subject to interpretation by the various compiler vendors, things like that. And that's a static analysis technique, and I'll talk about that in a minute. The other standard to look at that was mentioned previously is the ISO 26262, which deals with the electronic software components specifically related to safety, but certainly anybody can follow that. And that takes a risk management approach, so understanding and defining the risks for the application and the system, and then working to mitigate those risks. And so what most of these standards in any industry do is they look at the impact of a failure from minimal impact, no injury, or minimal injury to a catastrophic impact to a community with a software failure. So with a little bit of an impact, you don't need as much testing as if you have a defect that has a catastrophic impact. A lot more testing involved with that. So you can look to the lower end of that standard, the less safety critical end of that standard as a guideline to maybe get started with that sort of thing in your project. So if we look at what's behind those standards, we can break it down into a couple of different testing approaches. First one is static analysis. MISRA often falls under that. So static analysis is about assessing code quality just by looking at it, not executing it, just by looking at the code as it's written. And so compliance with a coding standard like MISRA is part of that, as well as some defect analysis and finding errors like divide by zero situations or misuse of memory, things that are certainly going to cause a failure. Get those weeded out if you can, right after you've written the code or as you're writing the code. And then the dynamic analysis techniques are more for when you are executing your code. So while the code's running, when you're looking at how it's behaving, setting up pass-fail criteria, that sort of thing. And so you can look at several levels of testing. There's unit testing, where you're looking at a single file of code and really isolating that and testing it thoroughly. Integration testing, where you're starting to gather together these multiple files of code and modules that make up a functional process, and you're looking at how they talk to each other and work together to get their job done. And in both those cases, you're really looking at a small subset of the entire application and building a test bed or a harness around it that can really control the environment under which it executes, so you can control the stimulus and the global data and drive it down all its paths and really thoroughly test it. Moving up from that, you can look at system or functional testing, where you're running the whole application to assess how it is meeting its requirements and making sure that it's doing what it's supposed to do. One of the challenges organizations run into during system testing is, how do you know when you're done? You can test all the requirements, but is that enough? And so we'll talk about how code coverage can help with that in a minute. And then lastly, there's the regression testing, the continuous integration, the repeatability of all this. It's not enough to test once. you've got to keep testing. And that's especially important now that these systems are so big and complex. One engineer working on one piece cannot possibly understand anymore the impact of a code change in another piece of this system. They just don't have that understanding because it's so big. This quote on the slide is actually from a customer of ours just from a couple of weeks ago talking about the benefit of using our tools. And he said, they found seemingly unrelated functionality being broken by code changes. So this is happening today on a regular basis in companies all over. So what is code coverage analysis? Code coverage analysis is data that's gathered during the execution of an application. And not only does it highlight what lines of code were executed during a test or a set of tests, but it highlights, more importantly, the lines that were not executed. The lines of code that have not been executed have by definition not been tested, and they are more likely to have bugs. So that's one area, one way to identify your risk, unexecuted code. And so beefing up your testing, regardless of which kind of testing it is, to cover more and more code is a risk mitigation strategy, absolutely. And the nice thing about code coverage is it's kind of easy to deploy, easy to get going, and you can deploy it through all those phases of testing. And it's especially important for any kind of legacy or already fielded code that you might be carrying over to a new project. So when you look at kind of the two different approaches to development or the two different kinds of projects, you've got projects that are all new development, and then you've got projects that have some legacy pieces to it. When you're doing new development, best practice is do thorough low-level testing. As you write the code, build some unit tests, make sure that code is working, send it down all its paths, start to integrate those modules together, do full integration testing, go down all those paths, and then as you move down the testing life cycle, get to system testing, functional testing, do some code coverage analysis, make sure it's thorough. In the end, you're going to have a well-tested application. And if you are following an Agile process, one component of Agile is test-driven development. So that is definitely built into that approach, building your tests early, even before you've written the code or in parallel to writing the code to make sure that you've got those fully fleshed out. For legacy code, typically you don't go back and unit test that. So you want to do code coverage on the legacy code and maximize the execution and the testing of all that code so that then you can make sure that you've got a well-tested application. So our product is VectorCast, and we are a testing tool. We fit in the right-hand side of the V model through all that testing life cycle and support the automation of a lot of those testing strategies that I mentioned. And we do work with all of the other products and vendors that you've heard about in this webinar, which is fabulous. I think we're all about kind of making our tools work with each other because, as someone mentioned, people don't use just one kind of tool for a lot of things. And then the last thing I just want to mention is that our VectorCast product is TÜV certified. So we're certified for use for safety-related software development. So even though you might not be doing safety-related development, it's nice to know that your tools have been certified to that level. So with that, I will turn things back over to Kurt.
Great, thanks, Linda. We are now to the Q&A portion of the broadcast. Again, we ask that you continue to submit those questions as we go on here. Manpreet, here's a question about collaborating with other organizations. So if this person is collaborating with other companies and they don't use the same kind of tools environment, can Rational help them control and coordinate these external releases from these organizations that may use different processes and tools?
Very good question, and a very important imperative for any tool evaluation at any company. If any vendor out there comes and tells you that they address all the needs for the whole engineering cycle, it would be really lying. So we at IBM have always realized this long back, and that you'll always have areas where our tools will exceed in capabilities, and there will be areas where other companies would have phenomenal solutions. So we developed a standard called OSLC, Open Services for Lifecycle Integration, and this standard is not is basically open standard going to be hosted on OSS pretty soon, and it is a very different approach to integration of tools from different companies. It is a significant departure from other integration approaches that we saw before in the last decade, where you would have to synchronize repositories and you would have to have a replicator running, and then latency challenges coming out of that. In this case, we adopted what the Internet does best and adopted the Internet-based integration approach, and we called it linked database integration. We offer a product called Rational Engineering Lifecycle Manager, which is basically this integration hub, which can help you bridge tools from different companies. We have right now integrations with Mentor Graphics, National Instruments, and are open to any other tooling company who wishes to join the party. So yes, long story short, integration is a very important aspect. End-to-end traceability across engineering disciplines is going to get very important, and a standards-based approach to integration, open approach is something that is in the DNA of our solution.
Okay. Yuri, there's a question about MATLAB Simulink. Does integration with MATLAB Simulink cover one or two-way synchronization?
Okay, so again, integrations are important. Yeah, we do have a connector between MATLAB Simulink and Polarion ALM Polarion Requirement Solution, and of course it's a two-way traceability, so you can publish your Simulink models easily to Polarion, embed them in a design specification document, so you don't need MATLAB Simulink to review the actual model, and you can estimate the impact on the actual model without opening the Simulink. But back to the question, yes, this integration is bidirectional, and the traceability can be navigated from both sides.
Okay. Andrew, there's a question about driver distraction and how that relates to touchscreen activities in the car. Can you discuss that?
So both consumers and car makers have become increasingly concerned about driver distraction. It's a major hazard, and we've all seen people driving along, talking on their smartphones or worse. And the NHTSA in North America, the National Highway Traffic and Safety Administration, have come up with a set of guidelines which they hope will be adopted by car makers and infotainment systems designers on what's an acceptable level of distraction. And distractions vary from cognitive distraction, because you're thinking about something else, visual distraction, and audio distraction. And they've come up with a rating scale, which starts at 1 and goes up to 20, 25, where they've tried to grade the distraction level of different activities. So it's deemed acceptable to change the tuning on your radio station driving along. That's basically rated as a 1, and that's the acceptable level. And then as you go up the scale, it becomes more and more unacceptable. So, for example, reading while going along is rated 3.5. Reaching for a moving object, something flying off your dashboard, is rated a 9, and so on. And it's currently the guideline is you shouldn't take your eyes off the road for more than 2 seconds, which is still a long time. So designers of the platforms that go into cars are looking for ways to minimize distraction. Technology like head-up displays coming into play, voice recognition. But even those require you to think about something else or to listen to something else, to concentrate on something else. So they all need to be rated and ranked on the distraction scale. It probably won't become law for some time, but I think the industry wants to agree on a set of acceptable standards that allow us all to drive safely. And we, as developers, will be looking at ways to make the systems as easy as possible to use without distracting drivers or passengers.
Great.
So sorry, rather a long answer, but it's an important subject.
Right, yeah. Okay, thanks. Linda, you have a pretty comprehensive layout of test-driven development, lots of static analysis and all that kind of stuff. There's a question about what if someone is nowhere? How is the best way to get started? Can you kind of take steps in the direction and kind of get to the end goal eventually? What would you recommend there?
Absolutely. I think it is very overwhelming to figure out how to start testing this big complicated thing. And the more data and information you have to help you build a testing strategy, the better. And that's why I typically recommend if you're not doing anything and you want to do something, start with code coverage analysis, because it does two things. One, it's easy to deploy, easy to get running. So you're not adding this big expense of extra testing, but you're learning a lot about what you're doing with your current testing. So you deploy the code coverage analysis, test the way you always have, and then you say, oh, wow, look over there. We're really not testing this well. Let's come up with a strategy for that little piece over there. So it helps you break the problem down a little bit and get started and not be overwhelmed.
Right. Okay, good. We're running short on time, and there seem to be a number of questions I'm going to try to group together into one kind of statement, and I'd like to go around the horn, starting with Manpreet. We talked a lot of the presenters talked about open source and automotive and things like that. Security holes within open source could lend itself to be even more problematic because of the huge developer base that's out there and the accessibility of the software. Maybe starting with Manpreet, we can talk about how is this addressed in the tools from an infotainment system perspective? How do you prevent these things from affecting the control and engine systems using various tools? Manpreet?
Again, excellent question. So absolutely, the security holes could pose a next paradise for the hackers, and the safety aspects in a car imply that there are very high stakes in case the systems are not secure. But unfortunately, there is not a very elegant solution to this problem. It isn't like you'll run a code scan that will basically find out vulnerabilities in your system and tell you where exactly to fix what. At IBM, we are working on adopting certain solutions that we have in the area of the web application development and AppScan, and which are basically automated scan tools that help you find the vulnerabilities like SQL injection and basically provide you a set of also recommendations as developer practices to avoid those. But that still does not prevent a hacker from taking control of your CAN bus and basically wreaking havoc.
Right.
So the solution for this, I think, is still in the nascent stage. We are partnering with another company called Black Duck, where they have a very good solution in terms of open source compliance. I'm right now at the Geneva conference in San Diego, and this topic was discussed. Believe me, the automotive community who are focusing on creating the next in-vehicle infotainment platform, generic in-vehicle infotainment platform, and also Tizen and automotive-grade Linux, I'm sorry, it's too many acronyms, are all very cognizant of this problem, and the amount of rigor that you see going in development of Geneva, it is not a very loosely controlled project. It has a lot of very good expert groups from the best car companies and tier 1 suppliers, and I think we'll have a very neat solution very shortly.
Okay, great. Yuri, do you have any comment on the open sources and compliance and infotainment versus control and engine systems and how open source affects that?
This is probably a bit out of scope of Polarion. It's just made a nice thing is that Polarion is based on open source technology heavily. We include many open source components, so we have a practical experience of that. And we confirm, that actually there is a great effort on validation of all those components that needs to be spent on the client side. It's just our practical experience.
Right. Okay. So yeah, I guess that attention to security risks and holes should be within the framework of the Polarion application lifecycle product as opposed to being built in. Right. Okay. Andrew, you talked a lot about open source initiatives and infotainment systems. Are things like Geneva and the Tizen, are they worried about security holes and ways to go from the infotainment and starting to get into the control systems? Is that addressed in those environments?
It's managed at the moment. Linux by itself is not particularly secure, but by putting it on a separate hardware platform, you can make it secure. By isolating it in the vehicle and what's able to run on it, you can make it secure. And the other comment on open source, I think, in the short time we've got left, is around licensing. If you use an open source license, you're obliged to make it available to downstream users. So car makers and designers are having to get their heads around the use of open source licensing and making that available downstream to drivers and passengers, a completely new concept.
Yeah, that's a good point.
A whole industry is emerging around this area of software management.
Okay, interesting. Linda, from a testability perspective, I'm sure you probably have some comments and suggestions on making sure that security issues and holes are addressed in the testability cycles, I would assume.
Sure. I would add that it's not just about testing. I think security needs to be addressed through the whole life cycle. You've got to have it built into your requirements. You've got to have it built into your design. So by the time it gets to the point where you're testing it, you're not thinking about it at that point because it's way too late. But absolutely, there's things you can test for. Typically, the security stuff is probably more of a systems level test. How are people penetrating this thing from the outside? But it can certainly be addressed in the whole testing life cycle.
Great. Unfortunately, that brings us to the conclusion of today's eCast. We want to thank our presenters for sharing these valuable insights into automotive systems development and test. We at Open Systems Media and our presenters all want to thank you for attending today and contributing those great questions remotely. This eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast version will also be made available there. You can do a web search with the keywords embedded space e-cast and find all of Open Systems Media eCasts available for download as MP3s. Thank you all for attending, and have a great day.